Hello students, let us start with another important topic, probability. In class 9th and class 8th, we have learned some of the important definitions related to probability. Branch of mathematics that measures the uncertainty of the occurrence of an event using numbers is called probability. The chance that an event will or will not occur is expressed on a scale ranging from 0 to 1. It can also be represented as a percentage, where 0% denotes an impossible event and 100% implies a certain event. Then what is event or outcome mean? An outcome is a result of a random experiment. For example, when we roll a dice, getting 6 is an outcome. An event is a set of outcomes. For example, when we roll a dice, the probability of getting a number less than 5 is an event. Likewise, we can define so many events. You need to note that an event can have a single outcome. If you recall, in class 9th we also learned experimental probability. Experimental probability can be applied to any event associated with an experiment that is repeated a large number of times. A trial is when the experiment is performed once, and it is known as empirical probability. Experimental or an empirical probability is given by P of E equal to number of trials where the event occurred upon the total number of trials. We also had discussed in class 9th related to theoretical probability. The theoretical probability is given by P of E equal to number of outcomes which are favorable to the event upon the number of all possible outcomes of the experiment. Here, we assume that the outcomes of the experiment are equally likely. We have discussed this equally likely. For example, when a coin is tossed, the probability of getting head is same as the probability of getting tail. Such type of an event is called as equally likely event. There is something called as elementary event. An event having only one outcome of the experiment is called an elementary event. Say for example, take the experiment of tossing a coin n number of times. One trial of this experiment has two possible outcomes, either head or tail. So, for an individual toss, it has only one outcome, that is either head or tail. You need to remember that the sum of the probabilities of all the elementary events of an experiment is always 1. So for example, take the coin tossing experiment. In this, probability of getting head plus the probability of getting tail is 1 by 2 plus 1 by 2, which is 1. Remember the concept impossible event. An event that has no chance of occurring is called an impossible event. That is, the probability of this event will be always equal to 0. For example, probability of getting a 7 on a roll of die is 0, as 7 can never be an outcome of this trial. Contrary to the impossible event, we have certain event or sure event. An event that has 100% probability of occurrence is called a sure event or a certain event. The probability of the sure event is always 1. For example, if a die is thrown, what is the probability of getting a number which is less than 7? Here there will be 6 possible outcomes out of 6 possible outcomes, so the probability is 1. You need to remember, range of a probability of an event is between 0 and 1. It is written as between 0 and 1 inclusive of 0 and 1, that is 0 less than or equal to P of E, probability of an event less than or equal to 1. This is probably a new topic, geometric probability. Geometric probability is the calculation of likelihood that one will hit a particular area of a figure. It is calculated by dividing the desired area by the total area. In the case of geometrical probability, there are infinite outcomes. This geometrical probability, in your higher classes, you will come across some situations where you make use of the geometrical probability. Another important topic is the complementary events. The complementary events are the two outcomes of an event that are the only two possible outcomes, that have got only two possible outcomes. This is like flipping a coin or getting head or tail. Probability of an event plus probability of not an event is always 1. Here, E and E bar, they are the two events, they are complementary events. The event E bar representing not E is called the complement of an event E. So for example, probability of getting a head is event, probability of getting tail is called as not event. With this basic information, we shall take up solving exercise question, and you will be understanding the concepts clearly. Let's take up the exercise question. Here is the first question. Complete the following statements. In the first sub-question, probability of an event E plus probability of event not E is equal to 1. The probability of an event that cannot happen is dash. Such an event is called dash. Probability of an event that cannot happen is always 0, and such an event is called as impossible event. Third one, the probability of an event that is certain to happen is dash. Such an event is called dash. The probability of an event that is certain to happen is always 1. Such an event is called as a certain event or a sure event. Fourth one, the sum of the probabilities of all the elementary events of an experiment is always 1. The probability of an event is greater than or equal to dash and less than or equal to dash. It should be greater than or equal to 0, less than or equal to 1. Now we have the second question. The second question is, which of the following experiments have equally likely outcomes, and explain. First one, a driver attempts to start a car starts or doesn't start. Second one, a player attempts to shoot a basketball. He or she shoots or misses the shot. Third one, a trial is made to answer a true false question. The answer is right or wrong. Fourth one, a baby is born. It is a boy or a girl. Let's answer each one of them. The first one, it is not an equally likely event. It is not an equally likely event, as it depends on various factors such as whether the car will start or not, and the factors for both the conditions are not the same. That is why the first one is not an equally likely event. Let's look at the second one. In the second case also, it is not equally likely, as it depends on the player's ability and there is no information given about that. Let's look at the third one. A trial is made to answer a true or false question. The answer is right or wrong. Here exactly the two options are there. So this particular event is an equally likely event. In the fourth one, a baby is born. It's a boy or a girl. So clearly there are two options given here. This particular thing is also an equally likely event. Let's take up the third question. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? When we toss a coin, the possible outcomes are only two, that is, head or tail, which are equally likely outcomes. Therefore, the result of an individual task is completely unpredictable. That is the reason why it's considered to be a fair way of deciding which team should get the ball at the beginning of a football game. So let me mention that when we toss a coin, the possible outcomes are only two. That is head or tail, which are equally likely outcomes. Therefore, the result of an individual toss is completely unpredictable. Therefore, tossing a coin is considered to be a fair way of deciding which team should take the ball at the beginning of a football game. Question 4. Which of the following cannot be the probability of an event? First one is 2 by 3, second one is minus 1.5, third one is 15%, fourth one is 0.7. The probability of an event is always greater than or equal to 0 and less than or equal to 1. That is known to us. We know that probability of an event is greater than or equal to 0, less than or equal to 1. Here, option B has negative value, which is not possible. Therefore, option B cannot be the probability of an event. Question number 5. If probability of an event is 0.05, what is the probability of not an event? We all know that probability of an event plus probability of not an event is always 1. So probability of not an event is 1 minus probability of an event. So probability of not an event is given by 1 minus 0.05, and this will be equal to 0.95. Therefore, the probability of not an event is 0.95. With this, I'll conclude today's session. We shall continue the remaining questions of the exercise related to probability in the next session. Thank you.